If you have any questions, let me know. Feel free to interrupt me in any of these presentations, unless if obviously we're running out of time, I may ask you to ask the questions at the end. But in this case, we're okay. Introductions to computers is our morning session. Our objective is to be able to describe overall how the computer works, including all the relationships between hardware and software itself. We want to be able to explain all the safety precautions and the tools to protect yourself overall. So, Jordan, you can read this out for us here.
Definition of a computer. Definition: electronic device for storing and processing data according to instructions given to it in a variable program.
Besides what we see here, can anybody name to me a type of computer that they're aware of that maybe some people just don't know that's usually there? Where can anybody tell me there's computers?
A router or Soho.
Good.
A gaming console.
What else? I'm sorry?
A gaming console.
Mm-hmm. And the other one was?
Cars.
That's right, our cars. Now, nowadays, if your computer breaks down in your car or starts getting faults or errors, it will give a false positive to the user, thinking that there's something wrong somewhere else. So these computers that are in there, inside these cars, are very vital just to be able to just accelerate. Or even sometimes brake. All that is being controlled by computers. Rockets to NASA that NASA uses to go to Mars, pretty sure have at least one little computer in there, right? Okay. So next one, who can I pick on? Eeny, meeny, miny, mo. Alexa. If you could read a supercomputer for.
Yes. Supercomputer. Fastest, too big for personal use as requires a facility to house, mainly used by the science community. Example, car manufacturing.
Cool. Teresa, mainframe.
Mainframe, lots of storage space, lots of input-output devices that can connect across vast distances. Example, servers.
Lázaro.
Microcomputers, called micro because of the chip being used, and affordable, first made by IBM and first to combine productivity with games. Example, personal PC.
Yeah, and we also have the mini computer. That's the faster than the actual microcomputer, as it states there. One of those are your point of sale machines that you'll see a lot of these places. It's like a little kiosk machine, looks like an iPad. In a lot of cases, it is an iPad that has a specific software in them. Our supercomputers, obviously, those are huge. Some of these are or require a special cooling. Some of them require nitrogen. Some of them have a special room where they call hot and cold aisles. We'll be looking at that. Mainframes are, as they said, are servers themselves, are huge and are used to store a lot of information and to centralize the share of information. So overall, you got the three main components here, or things that you can split things into. You have your hardware, you have your firmware, and you have your software. Can anybody explain to me overall, what does the firmware do for you?
The
It's
firmware is
basically
basically the communication between the software and the hardware, and it kind of helps connect everything together, especially with the motherboard and then to whatever operating system that's running on that motherboard to work together perfectly.
Very, very close. Yeah, that sounds like it. Someone else, I'm sorry, was trying to give also a definition before.
it was me. I think
I mean,
primarily
how you doing, me? I'm sorry, your name, me?
oh, I'm sorry, Carlos. It's Carlos.
Carlos. Okay, okay, cool.
Yeah, primarily just like doing an educated guess here. Primarily I think it's the process like input storage. If I'm correct. I'm not sure.
Okay. Good. That's very close. Both of you have some part of it. So we have the hardware, and I'm pretty sure everybody knows that one. That's the physical part itself. You got your monitor, your keyboards, your scanners, a bunch of stuff that you can touch. Usually hardware, the reason it's called hardware is because you can actually physically touch it, hardware. Now, your software is the programs that are used to be able to instruct the hardware how to do stuff. A lot of times, everybody knows who Windows is. Everybody knows what Apple iOS is. Those are the things that basically are used to be able to manipulate the hardware itself, and so that other programs can run on that to be able to spit that information back to the hardware. As for the firmware is what they have here as your BIOS chip and ROM storage. Your BIOS chip itself is the one that's able to recognize and does checks on all of the physical hardware that is being connected, including the existing CPUs, RAMs, all that stuff that's in there. This software that is installed on the firmware itself cannot be erased. It's stored there basically unless if somebody goes and messes it up itself. It now is able to recognize anything that's compatible to. When you go and you put anything in there, a brand new CPU, a chip or anything, it saves all of your configuration, the hard drive, all of that stuff that's connected onto what they call the ROM storage. That ROM storage itself now has everything that you have connected to the computer. If anything changes, then it rewrites usually onto it itself. So the firmware is basically, I think someone was saying, is like the communicator between the hardware and the software, more or less. But the software itself is firmware. After that, the hard drive and anything else does its job, and everything is done by electronics. So it's either 0 or 1 of pulsing electricity. There's not anything besides that. So you have your physical hardware. The firmware is usually a chip on the motherboard. There's firmwares on your video cards. So a lot of these things have firmware themselves. So I guess overall in hardware itself, as you can see here, you have a motherboard, you have your RAM. Can anybody tell me what this is here?
CPU.
Cool, cool. Thank you, Christina. How about this guy over here? Anyone else? Someone?
Power supply.
Good, good. Yeah, so as you can see, everything here physically you could see and touch. That's your hardware. You got your components, your connectors, you got slots, ports, peripherals. Anybody know what peripherals is? From what you hopefully have read?
Basically a projection, like your monitors are professional.
Peripherals, yeah, yeah. Basically, it's also you got your parallel ports, you have your connections for your audio. There's so many different peripherals that you can connect. So here's firmware itself. What we said is a startup instructions, low level hardware. Here's a chip of firmware you'll see usually on the motherboard or as I stated, some of these video cards, especially the gaming video cards, have their own firmware and even so don't be surprised to actually have to maybe repair a actual video card with its CPU or its problems with it itself. Anybody have any questions? Doubts? Okay. DeAndre.
Yes.
Okay. This is great. All right. If
Let me,
you read the slide, yes. The slide for us there.
okay, software, operating systems. User interface to control the hardware, manages communication with software, runs applications, controls input and output. Examples would be Windows, Mac OS, and Linux. Applications and programs. Perform useful human tasks, run on top of an operating system, are written for Pacific OS. Examples are Microsoft Office, Apple iWork, and games.
Thank you. So operating systems, though, are although they're getting very, very high level here, a little bit more complicated in that they have two phases, and we'll get into that later. But as simple as possible, there is what they call the shell of an operating system, which is what you could actually see. And then there's the another part, which is the kernel itself, which is the operating system, basically speaking in machine language, only in zeros and ones back to the hardware. And as you can see here, applications and programs run on top. And you have Excel, you have Word, you have Zoom, you got your Internet Explorer, Chrome. These are all applications that run on top of the actual operating systems and do not run on their own. I can't just go and turn on my computer and have Chrome. Oh no, never mind. I can just buy myself a Chromebook. But you get my point. You can't just have Internet Explorer as your actual operating system. You need something, either Linux or you need Mac OS, you need Windows, you need the Android operating system. Something's got to be able to control the actual hardware itself.
There are people that also can run like 3 different OSs. There's like a program for that.
That is correct. That is correct. And we'll be doing that on the later half of this, which is called VirtualBox. And we will be downloading and installing that onto our computers.
Cool.
Any other feedbacks or questions in reference to software? All right. This is the awesome part and the one that confuses the living daylights out of everybody. This is basically everything you need to know about computers. And then after this, it gets even worse when you have to do it yourself. So, how does a computer talk? Can anybody tell me how does a computer talk?
Ones and
Yes.
zeros.
Binaries.
Ones and zeros. It's only either on or off.
0 and 1.
Can it understand this screen here? If I talk to him like this, does it understand this screen?
No.
That is correct. We need to understand that ourselves. At no point can a computer understand anything, even artificial language. It's not artificial language. Artificial intelligence itself is not artificial intelligence. It's still zeros and ones. It's not humanly capable of doing anything except for what the human has taught it. Even when it's teaching itself, it's still zeros and ones. Do we all agree? I'm pretty sure Spock or anybody from Star Trek doesn't agree with me with their doctor, but it's still zeros and ones. And now what happens is with this, the humans have been able to create something so that we can understand it, which is the operating systems themselves and the programs. And they translate all these on and off within the computer itself back to whatever it is. If it's to the video card has specific zeros and ones instructions that it has to receive to turn on or off your three colors, right? I think it's red, green, and blue. All that is done by zeros and ones. So a bit, which is the smallest thing that is capable, as we said, was either zeros and ones, is one. In other words, one little thing. That is the smallest little thing you could have of information for a computer, right? Now, if I get 8 of those, it's called a byte. If I take just a little small piece of it, take a little nibble, you'll be surprised what they do here with these names. If I take a piece of it, a nibble, it is 4 bits. The majority of the information that is stored is in 8-bit increments. Another thing that we need to understand is that that's how a lot of this math is done, right? It's going to be done in what they call binary. So you're going to have to learn the multiples of 2. And the part that we're going to see here, as you can see, a kilobyte, in other words, 1,024 bytes. A megabyte is 1,024 kilobytes. And a gigabyte is 1,024 megabytes. Diego, how is it that you can do this? How is it that they got this number? This is basically how. Everybody ready? Because you need to write this down. 2 to the 0, anybody know what that is? 2 to the 0 power.
One.
That is 1, right? So if I turn everything off, remember the computer could only see zeros and ones. This is the easiest way you could do it and the fastest. He could only see it though, and don't ask me why, but we already said all off, it basically means that it is 0. So we're not going to get into that one, but we'll get into this one here. All right, so we said 2 to the 0 is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 64. 2 to the seventh power is 128. Now it continues on and on forever. So after 128, you have 256, 512, and then it comes 1024, then comes 2048, then comes 4096, and then it comes 81 something, I forgot now. But you get my point. You need to be able to get, though, to that 4096. The one that you will be using like crazy is this one, up to the 7th. You need to know that one very well, but the one, if you're going to get serious into the computers, you should be able to do up to 4096 in your head. You'll start remembering which one's which, but the exercise should be that you should be able to at least get up to 128. Now you're going to ask me, Diego, why would I want to do that? Because these are the only numbers that it sees. Can anybody tell me how would I tell the computer the number 3? I could only tell the computer to turn it on or off. How can I tell him the number 3 if he only sees 1, 2, 4, 8, 16, 32, 64, and 128?
It would be 0, 1. No, sorry, it'd be 1, 1. My bad. 1,
Yes.
1.
1, 1, 0, 0, 0, 0, 0, 0. If it was expecting a whole byte of information, which we said is 8 pieces, we all agree right now? Here's my 8 pieces from 0 to 7. 0 is counted. So that's my 8 pieces. For him to understand 3, it's seeing this in the background. That's what your operating system is sending in the background. How does he do that? He basically then turns on these 2 things. These are all zeros, so he's not going to count this. He's going to look at these 2 and he's going to add the values that are together. And if we add 1 plus 2 is 3. So let's do this. I'm in my head is what I'm going to do just real quick so I can show you one thing that's even cooler is that if you continue to do this little cycle, you'll notice that if I put all 3 of them together, it's actually 1 less than this number. So 1 plus 2 is 3. It's 1 less than this. So I have all of them off as 0. I have 1, 2. So in other words, this would be 0, 1, 0, 0, 0, right? We agreed already that 1, 1, right? So I keep on going. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sense? Questions, doubts?
I have a lot.
Good. So this is just the basics. We're not going to get into having that for the test, but I just want to make sure you guys understand that it basically is going through that. After class, for those that don't understand yet the machine language, feel free to stay. But what exactly don't you understand about the either on or off? Or at least that a bit is the smallest part, a byte is 8 of these, a nibble is 4 of these, and then obviously after that, a dozen 24 bytes is kilobytes, megabytes, gigabytes, and we have further deviations obviously after that. Is there a question in reference to that? Besides the Excel sheet, which we can look at after class, because that's going to be needed much more in the future when we get to the networking part. You guys got to have it ironed out. What I want you guys to understand is how to be able to at least use this 2 to the 0 power up to the 7th power ironed out, because you're going to need that to understand subnetting. Anyone else except that was DeAndre?
That was me.
Oh, no, that was Jordan? Okay. Any other question in reference to this though, Jordan? I will stay afterwards and review how I'm doing that chart if you like. But in reference to just understanding what 0 is, which is off, and 1 is on. Is there a doubt in reference to that for the computer?
No, I get that part.
Okay. So your confusion though is the Excel sheet back here?
Yeah, just like the actual math is the only thing that's tripping me up.
Okay. All right. So not a problem. We'll do this here. So what happens is when you multiply these 2 numbers, it gets this. So let's go like this. 1 times this. This will make it much easier. No, I can't do that here. Can I? It's equal to 2, and that was caret, if I remember. It's this guy, to the 1, to the 0. 2 to the 1. Two. You get it now or no? It's basically, it's just using 2 as the base. It says binary,
Okay.
It's either on or off.
Okay,
So
all right.
that's why you have to, and so humans understand the base 10, which is your usual 1, your 0 through 9, right? The computers can only calculate in binary and speak in binary. That's all it understands is either 0 or 1. And we'll get into the details of how it communicates that information to you, because it's doing it, even what's stranger, we're going to find out, is by electricity.
Right.
at times.
Okay.
All right.
Cool.
Any other question in reference to the base 2 or the binary notation that we were doing? Feel free, guys. That's what we're here for. Learn. All right. So now, how does it change? We found out how it changes to numbers. How does it change it to letters or characters? Well, ASCII is a American Standard Code for information interchange, came up with a binary system to represent the whole alphabet and all the numbers including there. And I believe they might come up with it now, but there is another one which has extended to all languages. I forgot the name of it. Hopefully they have it here. But you have the basic 128 and all the way up to 200 of the extended one from ASCII. As you can see here, here's your decimal. So if I had all zeros, that's a null character. If I have, it was equivalent to 36, right? So as we saw here, if I can create in the Excel sheet, if I can send it the value 36 would be 32. So I would turn this guy on. I would turn on this guy, and all the other ones would be send out zeros. What is gonna come out in ASCII is the $sign. You do not need to know this, guys. Please do not freak out. The computer is the one that needs to know this, all right? You just need to understand that that's what's happening in the background. And this helps you also in programming. For those that go into programming, your char character is needed because sometimes you're going to be creating scripts which require you to do loops and other things with the decimal notation and then convert it back to the actual character notation. But that's already high level stuff, but you just need to understand that that's how it converts zeros and ones into letters or characters. Any other questions? No questions? Okay. So your computer stages. If we can have another volunteer here. Okay. I'm not sure if I picked on you yet. Justin, I think I'm not sure if I picked on you, but I picked on you now. Go ahead, Justin.
A basic computer, basic computer process. Data comes in through an input device and it's sent to the CPU by memory. Then the second step is the CPU processes the data based on the input and the program installed in the memory. The third step is when the CPU is finished processing the data, it is presented through the output device as information, and the final step is the information can be stored in the computer memory.
So yeah, so that's the basic process for the computers. So if I start typing something, it obviously is an input, right? So a keyboard would be considered an input. An output would be my actual screen that I'm seeing here. They're both hardware, but one's an input and the other one's an output. In that case, so when I'm typing, it goes in, sent into the CPU via the memory itself, and then the CPU processes all those zeros and ones coming from the keyboard or electricity that came from the keyboard. And that's obviously how the BIOS, since it already says that that's a keyboard and the OS recognizes that it is a keyboard, it's able to understand what language, what all these zeros and ones that are coming to me, how can I translate that into that the hardware, I can spit it out into the shell of the operating system so that the screen can have what a human can understand. All that is done between the hardware and the software and the operating system itself. Any questions or doubts? So that's why I was saying, I think it was yesterday, where if you open up too much stuff, if you notice there, it keeps on doing what? Can anybody tell me what was in there 3 out of the 4 steps. There was a word there that was being used 3 out of the 4 steps.
CPU.
Another one? Correct, that's correct.
Processing.
The processor, yeah, the CPU is one of them, but what another hardware that's being used? So you had your CPU
Memory.
that was being pounded right now.
Hard disk.
No. I'm sorry, somebody said the word a second ago before that?
Memory.
Memory, am I hearing that correctly?
Yes.
Yes.
Yeah, so memory is the other one, because we'll find out exactly how that all goes on, but the memory and CPU play a vital role in performance of any computer, including obviously the hard drive and the video card if you're gaming. But overall, the ones that are hard hit and used like crazy is going to be your CPU, your memory. Without those two, you're pretty much useless. Any questions on this slide before we proceed?
Question. When you're referring to memory, you're referring to mostly RAM, right? Since the CPU mostly uses the RAM and only goes to the hard drive.
Correct. We do have 2 types of memory. That is correct. We have our RAM, which is our random access memory, and we have our ROM, which we mentioned earlier, is our read-only memory, and that was the firmware itself. The BIOS is a ROM. It's read-only. It's a program that's stored there, and then it has a CMOS storage area where it can actually store all of your information. But that software is hard-coded. Some of them, the new BIOS chips, allow you to upgrade them without any issues, and you can update them. And some of the other old computers, you have to take out the chip and put a new chip. Because basically, like I said, it was read-only memory. Good point. So what are inputs overall, as we can see here? Keyboards, drives, scanners, NICs, microphones, modem, anything that you can say that is giving in information to this. Make sense? Is there anything there that might be used as an output?
Monitor.
No, from the words that they put here. Sorry about that. From the words that they give us here, is there anything there that notices that
digital camera?
Digital camera.
And microphone.
Is it an output? Would I output sound through my microphone?
No.
The digital camera, I'll take that one for right now. Yeah, because you can kind of throw the pictures if you want in there to your SD card. It has 2-way communication, right? What's another one?
It has
There
a screen too. It has like its own monitor too.
Correct. Some of them do, yeah. There's one more
What about the NIC?
that they're not looking at, and you might just not recognize what it means. Can you tell me which one you don't know what it means? Because that's obviously the one that you guys are not.
Network interface controller.
NIC. It's a network. Yeah, that's right. Network interface controller. It is an input and it's an output, because you can receive information that you're downloading and you can be sending what you're uploading. So it's both in and out.
What does this stand for again?
Network interface controller. NIC. NIC card. Our next one area is the processing area. And as we said earlier, we have our CPU, or our central processing unit, the RAM, which was the random access memory, and then the drives themselves, and the motherboard. Out of here, who can take you down? Anybody know who can take you down really quick? If there's any problem, if it has any little problem on it.
CPU.
Motherboard.
The motherboard, that is correct.
Oh,
That's your backbone. You want to make sure you understand that. That's what a lot of times they call it, the bus. You hear the term that you're riding the bus. And that comes from an old terminology that's been out there, is because in a lot of the drawings, you'll see that there's like a line, a long line that comes across, and everything's getting connected. And here's your lines that they get the idea from. It's actually gold that's here, has the quickest electricity connection. It goes across and goes and connects to everywhere on the motherboard. Everything has to go through the motherboard. The motherboard is who basically has the BIOS chip, and then the CPU, the RAM, the drives, everything talk to each other through there. If you don't have the motherboard, or you have any little broken spot in the motherboard, you're pretty much down. Your drives is basically where you store long-term your information. So that's usually, everybody knows what that is. Your hard drive storage is the gigabytes or terabytes of information you can store long-term. You can install programs and save all that in there. And your RAM itself is the one that's used with the CPU to be able to process all of your information on the fly. RAM is only used while the computer is on, does not save the information there. Neither does your CPU. Your drive does. So your hard drive will store long-term. You turn off your computer, when you turn it back on, your Word document is there. Now, your Word document, when you open it and you're looking and editing it, although it's stored on your drive and is being updated on your drive, what's on your screen and what is being presented to you is actually between the RAM and the CPU, and obviously there's a sync going on back to the drive. But what you're actually using is here, and that's why I stated yesterday that if you open up too many computer screens or windows, you're going to start pounding these guys right here. Plus, he's trying to sync. So on top of that, you got these two guys working like crazy. You've got a syncing on of all that information in the background. Be that it's a hard drive for the Internet Explorer or to Word or to PowerPoint, whatever it is, these guys, and on top of that, obviously, the motherboard is also talking like crazy because he's got to deal with all of you. Because if the CPU is talking, the CPU talks to the motherboard tells the RAM. The RAM wants to tell the drive something, well, the RAM tells the motherboard tells the drive. It's got to go through the motherboard. So if anybody's got to talk, that's why she's called the motherboard. She's in charge. Questions or doubts on how the zeros and ones or electricities are going to be flowing through these things? That'll obviously help you when you're diagnosing things in the future, knowing how these things route. And you're also going to have to know soon where everything is in the computer. No questions on the processing and how it gets done? No. All right. So our outputs. We have monitor, our printer, and as we can see, our NIC card came here. And instead of a mic, we have our speakers, we have our drives. So we output and we input from our drives. And we have our modems also going out. So modems can connect in information, right? And they could also send out information, just like your NIC cards. Questions, doubts? All right. We got into the fun part where we go into our teams. So let me pause share for right now and pause recording.
You're muted.
Thank you once again. Thank you. Thank you. All right, before we get started, as promised, let's stretch out our legs, take a quick break. 15 minutes. I'll see you guys here in around 55. I'll give you 15 minutes, right? No, around 50, 55.
Sorry, what was that again?
1, 2, 3, 55. At 10:55, we'll reconvene. If you can take your morning 15-minute break.
Roger.
I should give you. I'll put it up here, a timer, so we could all see it. All right. Should have 14 minutes left.
For break team 1, I'm gonna send you the file right now. Okay.
Okay, sounds good.
Thanks.
So, thank you all for coming back. I think we're all back. All right. So, did any group get to at least finish it off, the actual activity, or still working on it? How you guys doing on it?
Break room 1 is finished.
All right, cool.
Room 3 is finished too.
Awesome.
Yep, same for 2.
All right. So, let me bring up the file itself. Sorry about that. Julie, can you tell me what your team put for number 1? That is, anybody have Julie or anyone in her team have an idea what that first device is?
That's not a game. A game console.
That's actually a what they call a SOHO router, a small office home office router. You usually see this in your houses or in the small offices. That's why it's called SOHO. So if it's a router is the device that helps you communicate to the internet. It has the capabilities of being able to send your information to the internet and vice versa. What did your team put, Julie, for number 1? Is it a input? Is it processing, or is it an output? Or is it both?
It's an input.
Input? Does everybody agree in all the teams that number 1 is an input?
No.
No? Christina, what did your team put? If you didn't
We
put
put both.
both, okay. Does everybody else agree with both? So far we have input or both. If we can use.
I lost some connection. Can you say the question again?
The question is, in the instructions, is to be able to review these 12 parts here to see if it's an input, processing, or an output. And when they mean both, that means that it could be an input and an output.
Oh, I did that wrong. That was my part. I thought I was naming it, but
Okay.
that one is both.
Both? Okay. All right. Number, does everybody agree then? So far we got 2 votes for both, 1 vote for input. And number 1 is both. As I was stating, you can send information out to the internet. You can receive information. So it is both an input and a output. Thank you, Julie. Thank you, and Christina. Levi, number 2. Can you tell me what number 2 is, Levi? Levi?
I can answer it.
Okay, Carlos?
It's an input.
It is an input. And what type, what is the device physically? Do you know what it is?
You mean the keyboard?
Okay, thank you. Yeah, I mean, it may be astonishing to you, but some people don't know that that's called a keyboard.
I did not know that.
Yeah, no, well, you'll be surprised. There's people that don't know parts of a computer at all, and they won't be able to tell you that that's actually a keyboard. So does everybody agree that that is an input?
Yeah.
Awesome. Let's see, who else can we choose here? LG, can you tell me number 3? Is that an input, a processing, or output, or is it both input and output? Number 3, LG. LG?
Wait, yeah. Process. Wait, give me a second.
Number
Sorry.
3, yeah.
For number 3, I believe it's processing, and it's a hard disk drive.
Everyone agree? Is it part of?
I thought we were just supposed to put if it was input,
Is it part of processing, or is it part of input?
It's part of processing, and it's an input.
Can I use it as a human to input information? And when I mean input, that means you as a human would do something to be able, if I use my mouse, I'm moving it around. If I use my scanner, if I use my mic, I myself can do something with it. Can I myself do something with a hard drive? So that if we recall on the slide of processing, we had the motherboard, we had the RAM, we have the CPU, and we had our drives. Our hard drives are part of the processing power. It is a hardware that does input and output data from itself, but as looking at it from a perspective of this type of terminology, it would be a processing.
I'm confused. I thought we were supposed to put if it was an input, output, or both.
Put it outputting, but I just want to make sure if we're also looking to see, is it a processor? So it's got both, right?
Oh, okay.
It also has processing, right? It's in charge of processing, but it is in both input and output. So if you put both, you are correct, but I just want to make sure that we understand that in the other chart that they had here, right? It's somewhere in here, right? We remember the slide, hard drive is in here. And I think if we looked at it, it was actually an input and an output. It was in both sides. And then it was also in here. So that's why I want to make sure we know that it basically, yes, it inputs and outputs information, and it's part of the processing too. Number 4, Alexa. Is it input, output, or both?
Output.
Everyone agree?
Yeah.
All right. Number 5, Jordan.
input.
Everyone agree?
Mm-hmm.
6, Teresa.
Would it be like a processing?
Okay. Levi, can you tell us what this device is? This one right here, number 6. Can you identify it? Not if it's input, output, or processing. Can you tell me what physically it is? I think you're on mute. I see you talking, but I think you're on mute. Or
yeah, sorry. I don't see that that image. Like, I see your screen right here, but I don't see that that image with all the numbers on it. I just had it here, but I don't know where it went.
okay. But looking at my screen overall, what do you think? Do you want me to zoom it in a little bit?
I mean, yeah, but I don't see like the numbers 1 through 8 at all.
What?
A little.
Yeah, this guy here.
Yeah, I don't.
I have the same issue, Diego. I see basically your Google Drive.
Yeah, that's all I see.
Yeah, same.
Awesome. Let me stop sharing. Just one more time. You see it now?
Oh, okay. Yeah.
All right. So this guy here. Oh.
Okay. I don't know exactly what it's called, but I think it's the access port. No, I don't know exactly what it's called.
Okay. Not a problem. Do we recognize what the little thing doohickey is here at the end of it?
Oh yeah, I know it's an antenna.
All right. So if it's an antenna, and from the slides that I presented, can anybody take a wild guess if it's using some type of communication? What would it be? It's going to be
Wireless card.
Wireless.
There we go. There we go. Yes. That's what a wireless card looks like. The ones that go into the computer itself. It has an antenna, and then that goes onto the motherboard itself.
Okay.
So knowing that it's a NIC card or a wireless card, is it a input, output, or is it processing, or is it both, input and output?
Both.
It's both, right? Input and output. Not part of the processing, but it is an input and output. Any questions or doubts on that one? Number 7. There's no questions on that one. Daniel, number 7.
7, that looks to be like a floppy disk, and that's like an input.
That is close. That is a...
Or that's like the disk drive.
DVD-ROM or a CD-ROM, one of the two.
CD-ROM.
A CD drive or a DVD drive, one of the two.
Okay.
And that
question: would optical drive be acceptable?
Yeah, an optical drive, because that encompasses both the DVDs and the CDs. And so it's input, right?
Yeah.
Now that's like a trick question, because if it was a read-write drive where I could actually write onto the CD, then at that point it would be both put in and out.
Okay.
Oh, so
a read-write drive.
It can be at times, but if it's just a player, if it's a DVD player, if it's just a CD player, then it's only input, right? Because it's inputting information via the CD. But if it's one that you could actually read and write to the actual CD, then it's both input and output. Because you can input information to the computer and you can output towards the CD. So you can then obviously take the CD and put it in any other computer. Number 6. I'm sorry, number 8. Pablo.
It's a camera, and as we talked about, it could be both.
Right, depending on the technology on the camera. There's a lot of them have that internal or that little card, SD card, that you can actually upload pictures to it. Usually people don't do that, but you have the capabilities as both. Last one, number 9. Jordan?
Output.
Everyone agree?
Yep.
Hopefully you guys recognize that. Want to take a guess, anyone?
Speakers.
Hey, good. All right, guys, so hopefully that kind of helped out. Last one here, we have the scanner. That we said was an input. Printer is output, and some of these all-in-ones are sometimes input and output. Can anybody tell me why the all-in-ones, or what is an all-in-one printer?
It has a scanner and it prints, or it could fax.
That is correct. It has all 3. It can scan, it can fax, it can print, it can copy, it can email, it can do a lot of things. So that would be considered input and output. And the last one we know is a mic, and that should be input. Any questions or doubts on this activity?
So 11 will be both, basically.
On this case, from what I can see in this picture, and we can.
And just
It's just a printer. It's just a regular printer.
Okay.
Just letting you know that if it wasn't all in one, just like I said with the CD, the optical drive over here, there is some cases where it is both.
Okay. Hey.
So the chart in the front, hopefully you guys were able to put in the little puzzle in the front where it fit the keyboard, the mouse, the microphone, your other outputs. You have your CPU. As you can see, the RAM and your drive is under the processing power. And then your outputs is your monitor. So that's basically how stuff flows through your computer. Everything's coming in through your inputs. Then your CPU, RAM, and drive take care of that. And then it spits it out either to a printer, a speaker, or any other type of output. Okay. Pablo, you're still helping me out with the chat room, right?
Yeah, sure. I'll help you out.
Okay, I just want to make sure for the week, and then we'll swap it out next week. We'll give that job to somebody. So if anyone has a question specifically that I need to answer or they're having trouble, just let me know. I know you guys are texting each other and stuff like that. It's not a problem at all. Feel free, but that way I stay on course. Thank you, Pablo.
No problem.
All right. So electricity, understanding and protection. All this stuff is running electricity. Doesn't matter where inside the computer there is flow. We have to be very careful to protect ourselves because we can get shocked. I've seen people who have gotten thrown with the old tube monitors from one side of the room to the other because they didn't properly actually discharge the device. You need to be able to discharge all devices, and you need to make sure you protect yourself, because not only can you maybe hurt or kill yourself, worse, you might actually damage the component and I got to go buy another one. No, I'm just kidding. You get my point. You can hurt yourself very bad, and then if you start damaging too many components, you're obviously going to start losing your jobs, because that is knowledge of something that you need to know and how to do, and we will be learning in these classes. Terminology we should know is the short. You got your volt, your watts, your capacitors, and transformer. Short, obviously, is a cut and flow of electricity. It actually also can be the increased flow of sudden temperature can cause that. So there's a lot of times in these server rooms and stuff like that, they have a specific humidifying device with air conditioning and everything, making sure that that room is in pristine humidity and air temperature so that you do not cause any type of shortage or electric shock in the room, because by itself, it can create a short. Next is the volt. That's we need to know. That is a unit of electricity. That is one of electricity force, and it's 115 usually in the United States. It's 220 out in Europe. Your watt is your unit of electricity that measures the amount of pressure, the power consumption of a device. So you can think of unit as being that little piece of electrical flow, for lack of a better word, and then watt is the amount of that you're pushing into it. So if you look at it in a hose that's pushing water, your volt would be your drops, and then your watt would be as how many drops or how much pressure you're running through there. You know that when if you have just a little bit open, then you're only going to running a little bit of volts. And if you open all the way open, you're going to have a whole spread of water or a lot of droplets, and that's your volts. Your capacitor is what holds the actual electricity. You'll see them. They're little round things on the electrical components. They look like little cylinders that are on there. Some of them are different shapes, but a lot of them are either cylinder shaped or other like a rough. And lastly is a transformer. We'll look here at a capacitor. Here's your capacitors themselves. and your transformers. Now your transformers themselves, anybody want to tell me or learn what was a transformer and what it does?
It converts electricity so that certain devices can use certain devices take certain voltages, so the transformer converts whatever the current is into the correct voltage.
That is correct. Does anybody know the voltages that are used inside the computer? So we have 115 outside or 220, as we said, volts right now. So what's the voltage that's used inside a computer? So you have the transformer, as we said, is going to do a change in ratio of the actual voltage and going to change it to something else.
12 volts.
12 volts is one of them. That is correct. It has 12, 5, and 3. Those are the major ones that it has throughout the whole computer, and we'll get into that and how it uses those voltages to create the zeros and ones that I was talking about. And depending on the actual voltage, that's how I know if it's 0 or if it's 1. Any questions on a short, a volt, a watt, a capacitor, or transformer? So protecting yourself from shock, always obviously disconnect from the any power source. Don't trust because you went and hit the button for the little, we call it a regleta, what do you call these things? The power surge protectors and stuff like that, because you just hit the button. No, you unplug it from the back of the computer always, or from the device directly, anything that's plugged, because some of these stuff has stored energy. So you'll always want to disconnect any device from electricity, take out the battery if it's a laptop. Obviously, some of the devices like the iPad doesn't allow you, but any device that you're going to be working on, you should always disconnect. And then next is ground yourself, all right? Make sure you are properly grounded. Obviously, don't ground yourself to power because that's not going to help you, but you want to properly ground yourself. One of the ways, anybody know how you can ground yourself?
You touch something metal?
Yeah, usually you want to do is, since you're dealing with something that has metal, your best bet is in the back of a computer, in the rear of the computer itself, it has screws. And the screws that you're looking for are the ones of the power supply. Usually there's 4 or more at the rear of the computer where you'll see this fan itself. So you'll see that on the fan or next to the fan itself, it'll have these 4 screws that I'm talking about. For instance, you have these here, those screws. And sometimes on the power supplies themselves, you'll see screws or on the fan. Those are the good ones that you should be touching if you do not have any other way of properly grounding yourself. Because at that point, you will make yourself at the same electrical current, static current that device has. So there's not a change in current. Everything has its own static electricity. It's that change in voltage that's going to create the power problem. Second thing that you want to do is, now that you have touched there and unplugged it, always press the power button. I know it sounds funny, but turn on the computer while it's plugged or unplugged. That's what you want to do. What this does is, physically, the power supplies and the capacitors that we just spoke of, the button is going to ask it to turn on. So everybody that had stored energy is going to release their energy, asking the power supply to do its job. Did that make sense? The moment that it releases its charge and is expecting that electrical current to come, it has let go of the energy that it had. So now there's no electricity left inside this computer. If you do not do those 3 steps, you are in high risk of either you yourself getting a shock, or damaging any component, especially the motherboard, if you touch it inside, because it's one of these capacitors will still have stored energy. Questions or doubts on this procedure? So, as I was saying, power supplies, printers, CRT monitors contain capacitors, and obviously those, usually there's special electricians for repair on those. Those you're not going to be asked to open up and start soldering and taking out a capacitor. You're not going to be messing with that. As for computers and opening them up and replacing a motherboard, a network card, or something like that, that you will, and so you need to know what you're supposed to be doing. Any questions on avoiding how to get shocked or how to avoid damaging a component? All right, so another, I'm sorry, someone had a question?
No.
Okay, so safety in to fire. We have your ABCs. Those are the main one that you need to know, and it gets simple if you understand the logic into it. Just remember this one key thing. A is for normal fires of wood, paper, and other combustible solids. And let's think about it that way. B is for fires that have to do with liquid, like oil or gasoline. And C is our friend. He's the guy that we're going to be looking for 9 out of 10 times, or 9.9999 times out of 10, because that one is a non-conductive chemical that puts out fires created by electricity. There's also things like halon and other devices that we will cover. And the halon devices basically suck out all the oxygen out of the room. So you don't want to be in that room when that device goes off. I mean, that all depends. Some people are bored. ESD is the electrical static discharge. Basically, when two objects, as I was saying earlier, have this similar charge and you touch each other, I'm pretty sure it's happened to you many times. You go and you're gonna give somebody a handshake and you feel that little shock. It's basically that. Your voltage compared to theirs, your static cling, maybe if you guys had bounce, is where the problem lies. And that creates that little discharge. Whoever has the higher, I believe, discharges to the lower. So that guy usually is the one that says, ow, and the other guy's like, I didn't feel it. He heard it, but he didn't feel it. So humans obviously can feel between 2,000 or 3,000 volts as a little slight zap. But obviously, unfortunately, computers are not that lucky. Over 100 volts of electricity on a component, and you have basically taken it down, and it's useless. That's how sensitive they are. To the point that in Intel, when I worked for UPS, I took a tour of their facility, and you look like one of these people in the pandemic, no lie, where you have to go into 3 separate rooms. So you go into this thing, what they call a man trap. We'll not learn about that. It's basically you come into a room where there's 2 doors. The door that you came into and the door that you're going to go into, which is the facility in there. You go in as one of these, before you put on your bio suit and all this stuff, you go into the other room where they spray you with, I don't know what kind of cloud thing goes on you. You go into the other room and you basically get all cleaned up, like if you were a doctor, put on gloves, all that stuff, and then now you can go into the next room. And the facility was very impressive. You couldn't touch anything, you couldn't do anything. Why? Because obviously that's where they're manufacturing the stuff, and it's so even the temperature controlled and everything is tremendous how that facility is done. Next is your ESD. Obviously, we said it can destroy the component and damage components so it's not working well, and it gives you these little strange errors once in a while, and it makes it very hard to actually diagnose the issue. So we got to be careful when we're dealing with this, because when we're working with a device to try to fix it, we may actually cause damage to something else and then cause, obviously, problems for the user that are sporadic. Any questions or doubts on protecting ourselves from ESD? Okay. Okay, Pablo, you can read for us the terminology here.
Yeah, so it has ESD bracelet, which is an anti-static grounding bracelet connected to a ground. Attached bracelet to the computer cases to ground it. We have the ESD mats, also called grounding mats. Then we have the anti-static bags, which are static shielding bags to store components. And then we have the ESD gloves, the electrostatic discharge gloves, which prevents the ESD between you and a device when wearing them.
That's correct. Thank you. So basically, you'll see here the picture of the bracelet itself. You see the little doohickey at the end over here. This is the bracelet you wear, and then it connects to this little wire. Now, the wire can either connect to an ESD mat. The ESD mat will have a place for you to grab onto, and then you put your computer on top of this mat itself. It looks pretty simple. And it basically is to avoid any more electricity from you being billed. You have sometimes the ones that you stand on, the anti-static mats, and the ones that go on the actual table, and the actual device will connect to the side of the actual mat itself, where it has a somewhere that you can actually connect to. Questions or doubts on the mat or the bracelet? See there, zoomed in now in the middle of my page, where you can connect to the little silver thing here. Everyone see it? So you take the black thing on the cable that's there with the yellow center, and you basically put that and onto the silver socket that you see there, and that will connect to your actual little bracelet. Next is the anti-static bags. I'm not sure if you guys ever seen it, but these anti-static bags are usually used on all devices that are sold to you. So basically, it's this little silver bag that you see here, which does not allow any electricity to come in and out. So you'll see your video cards, your memories, hard drives, all of them come inside this little thing. And so if I'm upgrading a certain device, what's expected of you is that when which you're going to learn the proper way of touching any device, you're going to be taking out the device, using this bag, and then putting the old device into there, because sometimes it's just an upgrade of existing, so you don't want to damage the component. So you're going to be asked to place it back in. So this is where you would use to be able to keep those devices from obviously being damaged. And the gloves are basically gloves that help you out to avoid any electronic static discharge. So instead of having the bracelet, you could just wear the gloves. Okay. Christina, if you could help us read the rules.
Protection rules, number 1. When working with someone else, touch the other person before you pass components between you. 2. Store components inside anti-static bags until ready to install them. 3. Always try to work on hard floors, not carpet. Use an anti-static mat. 4. When working on computers, check humidity to be sure it is not dry, which builds static electricity. 5. Remove packing tape and in another room, as these materials attract ESD. 6. Tie back long hair, remove loose jewelry and clothing when handling components and reaching inside the computer.
Thank you. Thank you. So anybody want to take a wild guess why we should do number 6?
Because your hair,
Yeah,
your
there's
hair attracts static.
It holds like
your hair can get also stuck in there, right?
And there's
The jewelry.
fans.
There's
Jewelry.
fans, correct, where your hair can get. Now the jewelry, why would I want to take off jewelry?
Because it could attract some kind of static.
It conducts electricity, so if I have any charge on me and my ring or my necklace, my gold necklace touches it, it'll connect 2 circuits. So as I showed earlier, the motherboard has a whole bunch of components on it, right? And if I have a jewelry which just taps the actual motherboard itself, any little part of this motherboard on that, what we call the bus or the superhighway that we're talking about, these little things here with all those little dots, if you flip it over, there's everything here in the back is mapped to each other. The moment that your jewelry hits one of these components, you're making a bridge from one side to the other that is not expected. It's only supposed to travel on the highway or the street that has been provided for it. Remember that we have 12, 5, and 3 at any given time running through this computer, and every single highway has its voltage. The moment you actually bridge these 2 connections, you can kiss it goodbye. Questions or doubts on any of the 6 rules? Anyone know why we should touch one another before passing a component?
To get rid of your static charge.
Or to make sure that, you guys don't have any.
So that is to make sure that we're both in the exact same level. Remember, we always have some type of electrical static charge on ourselves. We want to make sure we're on the same exact level as that person. We don't create that little when we touch each other. Usually on the shoulders is what I would do with my coworkers if I was passing something. And if nowadays, especially nowadays, another thing is we have that anti-static bag for the device. So just give them the device inside or the component inside the actual anti-static bag. Now we don't have to worry about anything. We're just passing them the anti-static bag with the device inside, and there's no need to worry about touching each other on the shoulder and creating any type of, what is it that we used to call it? Cooties, yeah. Cooties. Anybody still call it cooties? Nobody? Anybody know what cooties are? I'm not saying about
Yes.
Okay. All right then. So essential tools that we should recognize and learn to use is the grounding bracelet, the mat, anti-static gloves, the small screwdrivers, chip extractor, and a container with separate departments for our screws. We should always have extra set of screws, and they're usually all the same, almost the same exact size on purpose. It has the same threading and size, so it can be universal for a lot of these cases and or things that you're dealing with in a computer. Obviously, the computers are different than your phone or your laptops or any other mobile device. Those are going to be different types of screws compared to an actual normal computer. Those are usually universal. Post-diagnostics card. This card here basically is one of the things that helps you. Now, we mentioned that the BIOS already does that, right? So the BIOS goes and checks and does what they call a post-diagnostics of your actual computer. It checks to make sure that all the components that were supposedly there are still there. And it also makes sure that they are good. So it checks the memory, it checks the hard drive, and usually you hear a little beep. I'm pretty sure most of you guys hear that on your computer. And that's its way of communicating verbally to you, saying, hey, I'm okay. Go ahead and boot up your operating system at this point. And some of you actually might have heard maybe a long beep where it goes beep, 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 like about 10 times or 8 times. Believe it or not, those beeps coincide to the actual manufacturer letting you know exactly what's wrong with the computer, because it cannot show you on the screen. All you have is a black screen. It has to communicate with you in its own special Morse code. Lack of a better name. It's not really Morse code, but it is its own code. You could actually look up on the internet and say motherboard 8 beeps on boot startup. That sounds great. And you'll see here, I wasn't lying, that basically there's a problem with a read write. 9 means that it is BIOS. So it has short, long, like I said, Morse code, so that you could look those up and actually use those codes to determine the issue. Since it cannot put it up on the screen, obviously, that's what's going on. It's gonna have to somehow communicate with you. Make sense? And that is not a mandate of knowing what each one is. The mandate is knowing that you can look it up, because every single manufacturer has its own Morse code. Questions or doubts? So the postcard, this is a more sophisticated actual device. This, as you can see, I can actually install it onto the motherboard, or I can connect it via USB, depending on the actual postcard device. And this one now is going to give me a number. Instead of going beep, 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 it's going to give me a number. And the device itself comes with a book. That number, I look it up on the book, and now I know exactly what's wrong with the computer. Usually these are hardware issues where either the memory, CPU, your motherboard, something has gone completely wrong. And if you cannot get past the post, as I said, the post is what the BIOS does to be able to allow you to use the computer. Checks that everything's okay and allows you to basically use your hard drive and let you know, lets the motherboard, the CPU, everybody knows how to communicate with each other, because the BIOS contains that information. If I cannot recognize that type of hard drive on my BIOS, I'm the BIOS, then guess what? Nobody's going to be able to talk to this hard drive, because I don't have the book of how to talk to this guy. Make sense? So that's another thing with components, or looking for components on a computer. We have to be really aware of what's compatible with the motherboard that you're using, because the motherboard is the one that's going to be able to then talk and obviously translate all the zeros and ones back and forth. Questions or doubts on what a diagnostic card does? So it's going to go and do it what the BIOS does, checks all the components, and then instead of beeping, it's going to give you a number. You look it up in the book or on the internet, depending nowadays. Some of these books are on the internet, and it'll tell you exactly what hardware issue you're having on.
Quick question. Can an advanced host device also flash the BIOS if there's something wrong and you can actually install the application to it?
This is a diagnostic card. I haven't seen any of them that can flash a BIOS because of the fact that every single manufacturer of a motherboard has a different BIOS that they're using. I have yet to see any of these cards where you could just flash it. Usually what you do is download on a USB the BIOS from the manufacturer, if you have a BIOS that's upgradable or fixable that way, and then you can just boot up with that special USB and upgrade or repair your BIOS. Good question, thank you. Any questions in reference to the post diagnostic card? No? Okay. Next is our tools. We have our crimper here. That basically, if we can see, it allows you to crimp your RJ11, RJ45. It also strips the network cables, so that you'll be using that for your phone cables and your network cables. This here is a cable tester itself. You have the multimeter. You'll be using those at times, depending your job. Sometimes you need to measure electricity. You have your tone generator and probe. Your tone generator and probe are used with each other. Basically, these devices are used to tone lines. So let's take, for instance, you're in a large facility and then the label fell off the wall. You have no idea what number or what port that cable is going to, which they call the actual closets. There could be either the main distribution frame or MDF or IDF, which is the intermediate distribution frame. These closets are where all the cables and wiring go to. So the port on the wall goes all the way to a special closet where everything then goes and connects to your switches, or after that, it'll go directly to a router or over a fiber back to the main distribution frame where the main router is. So this little device, you can plug it in. As you can see, you have this to be able to slice the wire if necessary, and you have a plug that you can actually plug directly into it. Now you say, why would I want to create a little special device for myself and slice it? Well, believe it or not, if it is connected to a switch, Ethernet actually blocks the tone. So if I would actually go in here and connect this little doohickey directly into the port, and it's connected on the other side from the patch panel where the port is into a switch, I will not hear it on the other end. Don't ask me why. I never figured it out. I can only tell you it doesn't work. So what you want to do is slice it. So you'll have the different colors in there, and you want to make sure that you don't use the same pairs. There's orange, there's green, there's blue, and there's brown. So you just maybe use one blue wire and one brown wire, and then it will send the tone. And since it doesn't mix or send and receive, now it actually tones out to the other side. Very important. So that's the device you would be using on the side of usually where the user is or where you're starting from. And then this little device here is the device that you use to be able to what they call hear it. So it's sending out the tone and creating the tone, and you press this center button here to be able then to hear through the speaker. You'll hear a large noise going, then basically you found that specific wire or cable that you're looking for. Questions or doubts on how to use a toner or what a toner is? All right, you have a loopback plug, a punch down tool, and a Wi-Fi analyzer. Your Wi-Fi analyzer itself analyzes the Wi-Fi. It can tell you basically the strength of the actual signal in the area and the channels that are broadcasting. And that's what hackers sometimes use to be able to find what's available is a Wi-Fi analyzer to see what is being broadcast out there and on what channel. There is separate channels and everything. We'll get into that. A loopback plug basically is a special plug that just, instead of me having to connect directly to a computer to see if the plug is good, it creates a loopback. In other words, it loops back from the sending to the receiving and the receiving to the sending so that it can actually inverse the signal right back to the switch, and you'll get a little flickering light on the other side so you know that it actually, that everything is good on that port without the necessity of actually to run from one side to the other. Punch down tool, that tool is, as you can see here, is a special tool. It has two bits and 4 sides. So you'll see here now, the punch down tool is used to punch down all wiring. So be that it's for phone lines or for your actual network, it is used to be able to punch down the actual physical lines into the punch panel itself. As you can see in this one here, let's see, it has it actually taken out. No, of course they don't. All right. All right, this is much better. So you can see I can take out from here the point. Now another thing I want to point out is here it is actually. Oh, go this guy. Here's the parts that I'm saying. See, on one side it has what they call the groove or the one that kind of aligns everything. After you get professional, you don't need to be flip-flopping it. In other words, when you punch it, it'll actually only put it into the actual punch down. Here's the actual punch down unit on this side. So the wires will be punched down into this unit on the punch panel. So to guide it into place. And then when you flip this little bit onto the tip here, it has what they call the cutter side. And that side will actually, when you punch it down, it will cut the cable from separating it. We need to be careful because when we're using this device, if you notice, it has two colors. And if you read it carefully here, it says cut. And on the other side, the blue side, it says absolutely nothing. That means that on that side, when you punch down the actual wire, it will actually cut that side of the wire from the doohickey itself. So if I put the punch down to be in the inside, I'm going to cut the wire in the wrong place. I usually want to cut it on the outside. And then if we do it on the wrong side, we're basically have to redo everything. I'll find something, if possible, maybe on the lunchtime, and I'll show it either today or tomorrow. Or if you guys find something, please send it to me, and we can go over a little video of somebody punching down the lines and stuff like that. I don't want to waste your time on that right now. Any question on the tool itself or what it's used for? All right, that's the end of this session here.